and welcome to the video lecture series of data structures. But today's topic is insertion at first in singly linked list. Okay, before that we are going to learn about the topic which is very much important, that is known as availability stack. Hi, this is your instructor Janice Shah. So let's understand with today's outline. First we are going to learn about the concept of the availability stack. So then we'll talk about the singly linked list. And next we'll talk about the insertion at the first in singly linked list. So let's begin with the topic availability stack. Students, the availability stack, that means when we talk about like a linked list. Okay, so here we have the level linked list, that is 10, 40 and 50. All three nodes are there, and this is a singly linked list because the last pointer of the node is pointing to the null. So what is the availability stack? Just imagine a situation where in our memory, students, we have some empty spaces, or we can say the available slots, that means empty memory. These all empty memories are there in form of availability stack. Okay, so just imagine a situation that when you come inside a classroom, if you want a chair to sit over there, what you do? If I have a bunch of chairs over here, if I have a bunch of chairs over here, what you are going to do is you're just going to take one chair, okay, and then sit over there. If other students come inside my class, okay, he is again going to take one chair and take his seat. So this blank chairs, or we can say these empty chairs stack, is known as availability stack, same as in linked list for the memory. Because whenever I want to insert a new node, I am going to take available spaces from the available stack, available memory, going to take it and then assign a node or assign the data to that particular space. Fine. So such like this, we can take a node from the availability stack. Okay. So let me show you how the availability stack works and how this process we can do. So here we are. See, here students, we have the availability stack with us. This availability stack, what happens with this? See, the availability stack is nothing but it's a stack. So stack contains what? Top pointer, obviously, which is going to point the topmost element of the stack. Do not imagine this as an empty stack, students, because this is availability stack. Okay, so each and every spaces are very much important because we are going to use these empty spaces to make our new node. Fine. So right now this is stack, but I'm going to represent the stack using linked list. So this is my new availability stack, which is represented by linked list. Students, if you remember, our linked list contains two things. One is data, one is pointer. One is data, one is pointer, where my pointer is pointing to the next node of the list. So this is the same thing. Okay, what happens over here? This is my topmost node of the availability stack. Okay, its pointer is going to point to the next node. Its pointer is going to be point to the next node. Its pointer again going to point to the next node. When there are no nodes in the next, then what happens? The node pointer is pointing to the null value. Fine. So this is my availability stack, students, over here. So what happens? See, avail. What is avail, sir? Avail is the topmost pointer which is pointing to the topmost element of the stack. So only one pointer is there in availability stack, which is known as avail. So what is avail? Avail is the top pointer. Whatever the top pointer do in the stack, the same thing will be done by the avail. Right now avail is pointing over here. Just imagine a situation. Right now avail is pointing over here. Fine. If I am removing this node, now avail is pointing towards the down. Removing this node, avail is pointing to the down. Fine. So avail is the pointer which is pointing to the topmost element of the availability stack. Fine. So what we need right now, when we ask the computer for the memory or for the new node, the dynamic memory allocation. Okay, the same process, the dynamic memory allocation. Okay, so I am explaining the dynamic memory allocation of the linked list by using availability stack theory. Okay, so just imagine a situation if this is my availability stack and right now the avail pointer is pointing to the topmost element of the stack. What I want new node. I want a new node. That means I want to remove the topmost node of the availability stack and take it as mine. Okay, so what to do? Okay, see, when you want to remove some element from the stack, the top pointer will be decremented. Yes or no? Whenever you want to remove something from the stack, your top pointer will be decremented. Yes or no? Yes. So same like that, here we cannot decrement the available pointer. Here we cannot decrement the avail pointer. Why? This is not an array, students, this is a linked list. Okay, so if you write like avail is equal to avail minus minus, that means you are just going down one location of the memory. But here in linked list we have nodes which are not in a continuous memory fashion. It might be possible that your topmost avail node address is 1000 and the next will be 500, next will be 20, next will be 3000. It might be possible, right? So you cannot write like this, sir. You can directly decrement the avail pointer like avail is equal to avail minus minus. No, you cannot do that. No. What you need to do is you just need to move your avail pointer. See the difference in the words. See the difference in the words. I cannot decrement my avail pointer, but I need to move my avail pointer from the top node to the next node. Okay, so whenever you move your avail pointer from top node to next node, students, your topmost node is automatically deleted from the availability stack, automatically removed from the availability stack. Okay, so to do this process, what I need a new pointer. Why the new pointer? Because after removing the avail node, after removing the topmost node from the availability stack, okay, what is the value of that particular node? How we can represent it? We do not have anything to represent the particular node. Right now I have the avail pointer. Right now I have the avail pointer so that I can call it is an avail node. But after removing the avail from the topmost node to the next node, what should I call him? I cannot say anything. Okay, that's why I'm going to take a new node. Okay, friends, before introducing the new pointer, to you, let me say you something. Let me inform you something. Here I have the avail. Here I have the avail. Fine. So to understand the availability stack theory in a better way, I'm going to use some basic terminologies like the topmost node. Whatever the pointer is pointing to the particular node, that node is recognized by that name. Okay, see, what is the name of the top node? That is avail. Why? Because avail is pointing over there. Again, I'm repeating the sentence. I'm going to take a terminology like, if my pointer is pointing to this particular node, if this is my temp and temp is pointing to this particular device, then the device name is temp. If this is new, if new is pointing to this particular device, then this device name is new. So same like that, if my avail pointer is pointing to the particular node, then the node name is avail. Fine. Okay. Now, so what is the name of the next node? See, if this is avail, students, this is avail, then the next node must be link of avail. Why? Why? Because if you remember, our each and every node contains two things. One is data, one is pointer. Here we are representing our pointer as a link. Here we are representing our pointer as a link. So if we can say this is avail, then this must be link of avail because the link of avail is pointing to the next node. You can see. Okay, you can say if this is avail, then this must be link of avail because the pointer of the avail node is pointing to the link of avail. Fine. If this is avail, okay, this is the link of avail and this is the next node. If the avail pointer is pointing to this node, then this must be link of avail because the link of avail is pointing to the second node. Fine. So such like this, what I am saying to you that if this is node my avail, then next must be link of avail. If students, the next must be link of avail, then next the third node, the third node from the top is known as link of avail because the pointer of the avail. Because the pointer of the avail, or we can say the link of avail, which is the pointer which is directly pointed to the third node. That's why we can say the third node of the availability stack is pointed by link of avail. Fine. So now you can get the idea that how can we assign the name to the particular nodes. According to me, the name means the pointers. If the topmost node is pointed by the avail, then the name of the topmost node is avail. If the second node is pointed by the link of avail, then the name of the second node is link of avail. Fine, students? Okay. So now let me introduce the new node over here. How can we represent this thing in algorithms? So here we have like who points to whom. If students A points to B, then we can write like this A arrow B. If A points to B, then in algorithm we should write like this A arrow B. If we can say P points to Q, then we can say P arrow Q. Fine. This is for your understanding purpose because such type of terminologies we are going to use in our first algorithm, which is known as insertion of the linked list at the first position. Fine. Now, this let me introduce the new. So new is a pointer. So before removing the avail, what I should need to do, I should make a new pointer and assign to it to avail. Because after removing the avail, we do not have any name for the first node, whatever the topmost node. Okay, that's why I'm taking the new pointer over here, and new pointer is pointing to avail. So what is our first step, students? New pointer is pointing to avail. Repeating this, new pointer is pointing to avail. That means who points to whom? Who points to whom? New to avail. New to avail. New to avail. That's why we need to write like this. The step number one is to remove the available node from the availability stack. Step number one is new arrow avail. Why? Because the new pointer is pointing to the avail. That's why we must need to write like new arrow avail. Fine. Now, what will be our next step? Students, our next step is to move avail to down. Okay. Now tell me, if the topmost node name is avail, then the below of the topmost node is known as link of avail, right? So what we need to write is, now the avail pointer is moved down and it will point to the link of avail. Avail pointers move down and it will point to the link of avail. So here it is. Avail will go down and it will point to the link of avail. Fine. Now, if avail changes position, then the notation of the link of avail will also get changed. But how to write the second step? Who points to whom? Avail points to link of avail. Avail points to link of avail. So we can easily say that avail arrow link of avail. That is the second step that you should need to write in your algorithm when you want to remove top node. When you are inserting something in the linked list, you have to take every time node from the memory. So when you want to remove the topmost node, then you have to write like this avail arrow link of avail. Fine. Now, so this is now after removing the avail from the topmost to below. Okay, this will be our new terminologies. Now consider the first node as a new because the new pointer is pointing over there. Second node is as avail because avail is pointing over there. Now what is the name of the third node? First is new, second is avail. What is the name of the third node? Link of avail. Because the pointer of the avail is pointing to that node, that's why it's known as link of avail. Fine. And then its next node can be considered as link of avail. Its next node is considered the link of avail. Okay, so you can write like this also. Okay, so here it is. Once you move your avail pointer from topmost to down, now you are free to take your new node because it is not in the availability stack. Why? Always remember, stack is considered from 0 to top, queue is considered from front to rear, linked list is considered from where? First to null, first pointer to null. Okay, so here students we have our linked list, that means stack. So stack is considered from null to avail, because at the bottom we have null, at the top we have avail. So this is only our availability stack. So new is now out of the family of the availability stack, so we can easily remove that. This becomes my new node. It goes like this, see, and then it becomes like this, new, it pointing over here. There is no data in a new node, but its link must point to the null. Okay, so now my new node is ready to be inserted in the linked list. Fine. So this is all theory, all about the availability stack. So such like this, you can use the availability stack to take your very first node of the linked list. Okay. So whenever you want to perform any insertion operation, you have to do this. You have to write new arrow avail and avail arrow link of avail to take the node from the availability stack. Now keep this concept in your mind and we'll move forward our next step, which is known as the first algorithm of the linked list, which is known as insertion at the first of linked list. So this insertion, students, the insertion algorithm of the linked list are known as the functions. Why? Because inside these algorithms we are going to return the address of the new node or address of the first node. Always remember, in the all the algorithms, whatever I'm going to teach you in this all the session of the linked list, in all algorithms, in the Singly Linklist insertion algorithms, we are going to return at the end, we are going to return the address of the first node of the list, because we have to mention them that what is the starting point of the linked list. That's why linked list is considered always from its first node value. Who have the address of the first node? The first pointer. That's why in the parameter, students, I have x comma first with me. I have x comma first. So the whole algorithm name becomes function insert x comma first. Function, I have written function over there. Why? Because this algorithm is going to return the value or the pointer address of the first node. That's why it is a function. Insert first shows that we are going to insert at the first of the linked list, in the beginning of the linked list. Fine. X is the element which is going to be inserted as a data in our linked list, and the first, so first shows the value of the first pointer. So here we have the 10 with us, 10 first and null, 10 first and null. Okay, so this is our simple linked list. This is my availability stack. I always used to show you because you have to understand the concept of availability stack. So students, up to now, what we are doing, whenever we want to perform any insertion operation on any data structure, we use to check the overflow condition, right or wrong? Yes, we used to check the overflow condition whenever we want to perform any insertion operation over there. But in linked list, you cannot do overflow operation, or you cannot check the overflow condition. Why? Because the linked list is like a dynamic memory allocation. There is no fixed size of the linked list. You cannot make a fixed size linked list. Array is a fixed size. Linked list does not have any fixed size. If you want to add any node, you just go to the memory, take the free space from the memory, take it out, add as a node. Go to the memory, take it out, add as a node. That means there is nothing like overflow over there. You can insert as many as nodes you want to insert, until and unless you have enough spaces in availability stack. Fine. So what we need to do over here, when we cannot insert, that we need to find. As here there is no overflow condition. But what is the condition? The condition is underflow. Underflow of the linked list? No, students. Here we need to check the underflow of the availability stack. Just imagine the same example that I have explained in the previous session, that I have the stack of the chairs. Okay, 5 chairs are there. One student come inside my class, I'll give him the chair, that is my availability stack. Just imagine the 5 chair stack is known as availability stack. Okay, now one student come inside my class, I'll give him the chair, he sit over there, that means data is inserted. Fine, only 4 chair left. Again, second, third, fourth and fifth. Now I do not have anything. I do not have anything. 6 students came inside my class and asked me, sir, I want to sit. But there is no space. That means no space in the class. No, there is no empty chair I have. Availability stack is null. Okay, so I cannot allow him to come inside my class. So same concept occurs with the linked list. right now, if my availability stack does not have enough spaces, that means availability stack is pointing to the null. The avail pointer is pointing to the null. That means I cannot do insertion operation in singly linked list, or I'm not able to give any node to for the insertion operation. Fine. So very first condition that I need to check in the every linked list algorithm, that is the underflow during the insertion, and the condition is if avail is equal to null, then write availability stack is underflow. Then you need to write return first. Always remember, you have to return the value or the address of the first node of the linked list. Fine. So here the address of the first node of the linked list is first itself, because we didn't insert anything. Now, what is our concept, students? We need to insert something in the linked list. If availability stack has enough spaces, as like this in this figure, we have some enough spaces from the availability stack. Okay. So what I'm going to do is I'm going to take the node from the availability stack. And you obviously know that how you can take a node from the availability stack. How? First you need to assign a new pointer over there. So new arrow avail, that will be your first step. To remove the empty node from the availability stack, what we need to do? We need to assign new to avail. Okay, I did it. I assigned new to avail. Next, second step is avail to link of avail. Avail to link of avail. So avail will point to the link of avail. So once I did this, my new node is free to take from the availability stack. So here I am free to take my new node. So students, this is my new node and it goes like this. See, this is my new node. This is my new node. So after completing this second and third step, I get my new node to insert in the linked list. See, I did not insert the new node in the linked list. See, there is no connection between both nodes. Okay, what I did, I just take a new node and put over there. Okay, now first initialize the field of a new node. See, each and every node contains two things. One is data, one is pointer. Students, in our algorithms, data are known as info. In our algorithms, data are known as info, and the pointer variable is known as link. This is the data, this is the pointer. Data is known as info, the pointer variable is known as link. So students, I need to initialize both of them. Okay, so first, how to initialize that? Tell me, what is the name of that particular node which we take? That is new node. Okay, so we need to write like this: new data, no, data of new. See how? Info of new. We cannot use data. Here I am using info word instead of data. Okay, so info of new arrow x. That means I am going to insert x in the info of the new. That is, see, info of new arrow x. After writing this statement, my value is inserted over there in new. Fine. Now let's move towards the next steps. See, this is the situation where I want to insert a node at the beginning. At the beginning. So students, if I am considering this particular new node, if this is my linked list first node, and I'm going to insert over here new node. Okay, so link of the new node is pointing to first. Link of the new node is pointing to first. Okay, that means pointer of the new node is pointing to the first node of the list. Then the new node is inserted. We can say the new node is successfully inserted in the beginning of the linked list. Yes, we are going to do the same. Okay, how? Let me show. What? Who goes to point who? Who points to who? The link of the new node. Link of the new node is pointing to first node. That's why we need to write link of new arrow first. Link of new arrow first. So here it is. See, my new node link will be disabled and connected to the first node. So after this, we can easily say, this is my first node, students. New becomes my first node, yes or no? Because in this, after insertion, new becomes my first node. That's why I need to write like this. Step number 5, return new. Return new. Why? Because I already told you, after performing insertion operation in linked list, you need to return the address of the first node of the list. So here I have inserted new node. See, here I have inserted a new node at the beginning of the list. At the beginning of the list. That's why the algorithm name is insert at first. Insert at first, where we need to insert. If this is my first node, we need to insert at that part. Okay, so we need to insert over there only. That's why after inserting, it becomes my first node. So I should write that return new. Fine. So this is all about the availability stack. How you can get the availability stack? By assigning the new pointer to avail and avail to link of avail. You will get your node. After that, just initialize the values like info of new, arrow x, info. We are using the info term. Okay, instead of data, we are using the info term. We should write like this, info of new. That shows the information of the new node. New node, that means a node which is pointed by new pointer. Fine. We used to see, we already seen about that how can we assign a name to the particular node. Name, that means a pointer. We already seen that who points to whom. That means if A points to B, you need to write A arrow B. P points to Q, you need to write P arrow Q. Here avail points to link of avail, you need to write avail arrow link of avail. Fine. So such like this, we can perform the insertion operation at the first of the linked list and understand the concept about the availability stack. Do not forget to watch this video again for the next algorithms, because each and every algorithm we need to perform 3 different steps. 3 common steps are there. One is check the flow condition. Second one is to take the new arrow avail, and third one is avail arrow link of avail. So just understand these concepts very carefully. Fine. If you have any doubt in this lecture, students, you feel free to ask me. Thank you so much.